All right. What should my pictures look like? What should the pictures look like that model this situation? Based on what they described, what kind of shape would make sense? Rectangle. Let's start with that. A rectangle to represent the building. Okay. All right, so here we have our building. We do not know how tall that building is. What do we know about the building? Cast a 25-foot shadow. Where would the shadow be? Like if I was going to draw the shadow, add it to this picture, where should the shadow go? Next to it. Going which way? Vertically, horizontally, diagonally? Horizontally. Because it's going to be on the ground, right? And hopefully this building has been built on level ground. All right, so here's our shadow. We know that that is 25 feet. What else do we know about? The painter passed a 3.5-foot shadow. So I'm going to go ahead and draw our painter here. And again, that shadow is going to be along the ground. Three and a half foot. Do we know anything else about the painter or the building? The painter is 5 feet tall, so this distance right here is 5 feet. Fantastic. And now think about how the person and the ground, or how the building and the ground are situated against each other. If I were to ask you what kind of an angle is created right here between the building and the ground, or between the person and the ground, what kind of an angle would that be? It'd be a right angle, assuming we're on level ground, which is a pretty reasonable assumption here. So we have a right angle here. So they didn't say this, but if it's casting a shadow, the sun is going to have to be like over here somewhere, right? The sun would have to be behind, and so that the shadow goes forward. All right. So we've got the sun's rays kind of coming down like this. So it's creating a triangle between the sun's rays, the shadow, and the object making the shadow. So we can do that on both of these. So I have these two right triangles that are similar triangles. The sun is at the same angle for both people, right? Because it's at the same time. We know they're making a right angle with the ground. We've got these two similar triangles. And I know two sides of one triangle. I know one side of the other triangle, and it is this distance right here that I don't know. We're trying to figure out how tall that building is. Do I know how big the corresponding part for the painter is? Yes, so we can find the scale, or I can set up a proportion, same thing as the scale. Do you guys want the painter to be in our numerator, or do you want the building to be in the numerator? Building sounds fine. Does it matter which one we choose? No. So let's go ahead and put the building in the numerator. I know the building's shadow is 25. What would that correspond to for the painter? 3.5. What should go in my other numerator? Question mark or X or some unknown, right? You guys okay if I put an X there? Is there anything wrong if you want to put a question mark there instead? Nope. This is the thing that we're going to be finding. You can represent that with any kind of an object or a variable or a symbol. This is what we're looking for. And then what should go down in the denominator? 5. Beautiful work. The thing that we want to figure out here is X, right? And X is part of this fraction. Whoever's phone is going off, please just put it on silent. I don't want X to be part of a fraction. I want to get it by itself so that I know exactly how big X is. What kind of an operation can I use to get rid of the fraction? Multiplication. And we know if you do multiplication to one side, all right, let's see if we can finish this out. If I'm going to multiply something to one side, have to do it to both sides, so I'm going to have to do it to this side as well. And what should we multiply by to get rid of the fraction? 5. Is it always going to be a number that we multiply by? No, it'll always be whatever's on the bottom of the fraction, whether that's a variable or a number. So I'm going to cancel that out. Now I'm going to grab my calculator. We're doing 5 times 25 divided by 3.5, or 25 over 3.5. We're not going to get a whole number. That's okay. Let's take it out to, say, 2 decimal places. Can you read that out to 2 decimal places for me? 35.71. Oops, I wrote 37. 35.71. Should we have any kind of units with that? Feet. So that building is 35.71 feet. Very, very nice work. We have a couple of problems to finish up in your extra notes packet that go along with this section. And then we're going to do a couple of problems that are in your book. So you're going to need to have both of those things, but we're going to start off in the extra notes first. We had just finished up question number 5 at the end of the period yesterday. And so we are ready to start on question number 6. Question number 6 says triangle GHL has been dilated. So I know that GHL is my new or my original? That is my original. Triangle GHL. So I'm going to trace around that so that I can see it a little bit better. GHL is this big triangle here. It was dilated to create triangle GJK. So here's my new. Here's GJK. So these are the 2 triangles that are similar that we're comparing. Was GHL enlarged or reduced? Did the original one get bigger or smaller? Got smaller. Remember, my original one is the blue one, and then it was dilated to create the red one, which is smaller than the blue one. So this would be a reduction. So it got smaller. We want to find the scale factor, and we want to find the values of x and y. Well, let's find the scale factor first. I need to write a proportion. I need to write a fraction that's comparing these 2 triangles together. Scale factor is new over original. Where are my two numbers that I can use to make a fraction with it. I can use to make a proportion because they're corresponding sides. 30 and 10. Those would be corresponding sides between these two triangles. So because we do new over original, I'm going to have 10 in my numerator. And I'm going to have 30 in my denominator. Can that be reduced down at all? To 1/3. We can take 10 out of both the numerator and the denominator, and so our scale factor is 1/3. All right, there's one piece that they asked me to do. Now they want me to find the values of x and y. Let's go find x. Where's x in the picture? GH. X is this side right here. So GH, the length that x is referring to, is that part of my new triangle or my original triangle? Original. All right, so I know scale factor is equal to new over original. We just figured out previously that that scale factor is 1/3. So I have 1/3 equals GH, which is that length x that we're looking for. You said was part of my original triangle, so that's going to go down in the denominator because that's where we put original. What is the corresponding length on my new triangle? GJ, which is 6. So I put 6 up in that numerator. So far, so good? All right. I've got some fractions to work with here. This time I've got two fractions instead of just one fraction. And x is down in my denominator. This is kind of similar to the warm-up because we had two fractions in our warm-up with an equal sign in between them. I need to get rid of the fraction where x is. How do I get rid of fractions again? Multiplication. What should I multiply by? X. We're going to multiply by the denominator x. Could I multiply by the denominator of 3 and get rid of the other fraction? Yeah. And there's going to be some other problems where we have to do stuff like that, but for this one, it's probably easier if we do it like this. So I'm going to cancel that out. So over on the left, I have 1/3 x equals 6. I still have a fraction over here with x. I don't want a fraction with x. I want x all by itself. What operation undoes fractions? Multiplication. So we're going to multiply again. If you do it to one side, you got to do it to the other side. This time I'm looking at this fraction. It's the only fraction I have left. What's on the bottom of that fraction? 3. So we're going to multiply both sides by 3. The 3 here that we're multiplying by and the 3 down in the denominator are going to cancel each other out. And so what I have remaining on the left-hand side is the 1 and the x. So I have 1x equals, what is 6 times 3? 18. And 1x is the same thing as just x, or you can divide both sides by 1, but if I divide by 1, it stays exactly the same. So x is 18. Then we need to find y, and then we'll be done with this problem. Scale factor equals new over original. Scale factor is what again? 1/3. So 1/3 equals, is y part of my new triangle or my original triangle? New. Y is right here. It is the distance from G to K. part of my new triangle, so it's going to go up in the numerator. So I have a y up here. What's the corresponding side on my original triangle? Not 2x. 24, there we go, right down there. 24 goes in my denominator because it's part of the original triangle. What I'm looking for, y, is part of a fraction. We've got to get rid of a fraction. What should I do to get rid of the fraction over here where y is? Multiply both sides by 24. So it cancels the 24 out in my denominator on the right-hand side. On the left-hand side, I need to multiply 24 and 1/3 together. What is 24 times 1/3? 8. 8 equals y. Nice work. All right. Let's look down at number 7. We have 2 parts to number 7. We have an A part and a B part. Here they're telling me that these 2 polygons are similar to each other. Yesterday we learned how to read a similarity statement, so I'm going to be able to find which sides are the corresponding sides that go together here. Does it tell me which is my new and which is my original? It doesn't say anything about it being dilated, so we're going to have to make a decision. Do we want the small parallelogram in our numerator, or do we want the big one? Because we have to stay consistent between these. Which one do you guys want to do? Small or big in the numerator? Big sounds good. So we can put our big, this is going to go in the numerator, big parallelogram in the numerator. We're going to put the other one in the denominator. Does not matter which way you decide to do this as long as you stay consistent. We've got x's in 2 different spots. There's an x right here, and there's an x down here. I don't know what the scale factor is, but I know these triangles are similar, so that means these proportions, these fractions, are going to be equal to each other. We said these were going to go in our denominators. So I'm going to need x plus 1 in one denominator. And I'm going to need 3x minus 7 in the other denominator. Now I have to find what they correspond to, and I have to make sure that I'm getting it right. So x plus 1, that's side zy, right? Here's zy in that similarity statement. And that means it corresponds to what on my other parallelogram? ST, last 2 letters here, so we're going to go find ST. There's ST, so 9 is what goes in the numerator of that fraction, because those 2 sides are corresponding based on my similarity statement, zy and ST, so they have to make a fraction together because they're corresponding sides. So what is the side that corresponds to ZW, the 3x minus 7? What corresponds to, what'd you say? SR. Here's ZW, middle 2 letters. SR is middle 2 letters. So it corresponds to this. This needs to go in my other numerator. We haven't had a fraction where we have x's on both sides yet. I'm going to need to get rid of fractions, which means I need to use what operation? Multiplication. Multiplication gets rid of fractions. We got to pick one fraction to start with because we've got x's in both of them. I'm going to have to use multiplication twice. Let's get rid of this denominator first. I could pick either one. I'm just going to start on this side. Just, I don't know. It's what I feel like today. Thank you. So if I want to get rid of the denominator, x plus 1, We're going to use multiplication. We're going to multiply both sides by x plus 1. So that's going to cancel out this denominator. I still have 9 remaining on the left-hand side. Now here's the thing that is really important to remember when we're working with these. When I multiply a fraction, like this side right here, by something that is not a fraction, we're going to need to use distribution, but only with the numerator. We don't distribute to the denominator. You only distribute to the numerator. So the 12 is going to get distributed to both of these parts, but the denominator stays the same. What is 12 times x? 12x plus 12 times 1? 12. And that's going to be over my denominator that stays exactly the same. 3x minus 7. I still have a fraction that has x in it. What operation do I have to use to get rid of that? Multiplication. If you do it to one side, you have to do the same thing to the other side. So we're going to multiply both sides by what? 3x minus 7. So that's going to cancel my denominator here. The 9 gets distributed to both the 3x and the minus 7. What is 9 times 3x? 27x. Minus 9 times 7? 63. Does anybody know their trick for multiplying 9s in their head? Actually, not in your head, it's on your fingers. Real quick trick for multiplying 9s, because I used to be so bad at this. You pick one side to start from, like over here. If I want to multiply 9 by 7, I go 1, 2, 3, 4, 5, 6. I put down my 7th finger. Everything to the left, that's my tens place. Everything to the right is my ones place. So I have 63. That's a real quick one. All right, so 27x minus 63 equals 12x plus 12. No more fractions. Two-step equation. Where are my x's at, though? They're on different sides. I got them on both sides. First thing we have to do is get the x's to the same side together. I usually decide to subtract the smaller one. Which of these x's is the smaller one? 12x. So let's minus 12x from both sides. What is 27x minus 12x? 15x. 15x minus 63 equals 12. What should we do now? Add 63 to both sides. So I have 15x equals what? 75. To finish this up, getting x all alone, divide both sides by 15. And x comes out to be 5. You're absolutely correct. Fantastic work. All right, part B. Part B, I have triangle KJL is similar to triangle XYZ. When we're talking about similarity, my sides are proportional, but over here on part B, do I have information about the sides? What's marked on these two triangles if it's not the sides? The angles. What's true about the angles between similar triangles? Same, they're congruent. The corresponding angles are congruent. And we can read this similarity statement to figure out which angles are the corresponding congruent angles. We know that angle K is congruent to what angle on the other triangle? Angle X. So I'm going to go ahead and mark that on my picture. Angle K is congruent to angle X. Well, angle X is 71 degrees. And what does it say about K? K is Y degrees. So how big is Y? 71. Angle X is congruent to angle K. So the measurement of angle X is equal to the measurement of angle K. So 71 is equal to Y. We're still going to need to find what X is. Which angle has X with it? Angle J, right here. And according to my similarity statement, angle J is congruent to which other angle? J is congruent to Z. J is congruent to Y. Look, they're both in the middle of my similarity statement here. J is congruent to Y. Well, they didn't tell me how big angle Y is. How am I going to do this? What do we know about the three angles in a triangle? They all add up to 180. Do I know how big the other two angles are? So can I figure out how big angle Y is? Absolutely I can. So I have measurement of angle X plus measurement of angle Y plus measurement of angle Z equals 180. Angle X is 71. We don't know how big angle Y is. Angle Z is 44. I should probably be doing this all on the other side where I have some more space. What is 71 and 44 together? You said 115. Sorry, I didn't hear the last part. I couldn't tell if it was 15 or 50. There we go. So the measurement of angle Y plus 115 equals 180. We're going to subtract 115 from both sides. So how big is angle Y? 65. So I'm going to add that to the picture. This is 65 degrees. So how do we find X? Yes. We know from the similarity statement that the measurement of angle Y is equal to the measurement of angle J because angle Y is congruent to angle J. So I have 65 equals what? (4x minus 13). Where do I go from here? Add 13 to both sides. 65 plus 13? 78. 78 equals 4x. Divide both sides by 4. And 78 divided by 4 gives me what? 19.5. So when I have similarity, if they're telling me about the sides, they're proportional. I'm going to write fractions. And if I have information about the angles are congruent. So I don't write fractions, I just set things equal. But I have to make sure to read that similarity statement. Be careful, because I know a lot of us, even myself, when I first looked at this, when I said, oh, I'm going to take 4x minus 13 and set it equal to 44. And then I looked at the similarity statement. I said, no, it's not equal to 44. It's equal to angle Y. And then we have to go in and figure out angle Y. Very nice work. I want you guys to grab your books now and open them up to page 469. Page 469. So page 469 has our similarity theorem. Two polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. We have talked about this. We wrote it down yesterday. It's written in our book. Really important that we remember there's those two criteria. Angles are congruent, sides are proportional. And then we have three properties for similarity. We have the reflexive property of similarity, where it's the same on both sides. We have the symmetric property of similarity. With the symmetric property of similarity, we switch sides. And then we have the transitive property of similarity. If they're similar to the same thing, they're similar to each other. I have AB is similar to DEF, and DEF is similar to XYZ. So then ABC would be similar to XYZ. They're both similar to DEF, so they have to be similar to each other. I don't want to go over example 1 because they've done almost all of example 1 for us. But I do want to switch the page and look at the check because you guys do have several homework problems that are just like this one. And we did this yesterday, but we only had one example of it, so I wanted to do another example in your book here. It tells me right here with this similarity statement that these two trapezoids are similar to each other. According to the similarity statement, angle N is congruent to what other angle? Angle U. So angle N is congruent to angle U. What about angle P? Yep, P and V. Angle Q. Q is congruent to S. And finally, angle R. Angle R is congruent to angle T, yes. So there's my corresponding congruent angles. They also want us to write a proportion that relates the corresponding sides. So let's pick out a side on our larger trapezoid. Which side do you guys want to start with? NP? Sounds good. So I'm going to have NP in my numerator over, when I look at side NP, because I marked my angles all up, I noticed that N has just the one congruence mark on it and P has two congruence marks on it. It's also the first two letters right here in my congruence, or sorry, not my congruence, my similarity statement. That's going to correspond to what side on the other trapezoid? UV. One congruence mark, two congruence marks, first two letters here. All right, let's pick out another side. Pick out another side from the big. Use PQ sounds good. When I look at my similarity statement, PQ is the middle two letters. And so that would correspond to what on the other one? VS. So PQ over VS is equal to, give me another side, QR. When I look at my similarity statement, QR is the last two letters. And so that would have to correspond to which side on the other trapezoid? ST. There's one side on each of these that we haven't talked about yet. On the big trapezoid, we have not talked about which side? NR. And that corresponds to which side on the other trapezoid? TU or UT. Does it matter which order you put the letters in when you're writing the segment? No. Flip over to 471 real quick. 471. We're going to look at the check that's at the bottom of the page. Let's set up this proportion. We want to find x. Here's the expression with x in it. It's on side LM. LM corresponds to what side on the other triangle? ST. This side right here. So I need a fraction that has 6x minus 3 over 3. And then I have this side that is 4. That's side JM. That has to go in my numerator because the 6x minus 3 went in my numerator. That corresponds to what on the other triangle? QT or TQ, which is 2. So that goes in my denominator. What is 4 divided by 2? 2. So 6x minus 3 over 3 equals 2. How do I get rid of the fraction that I have left? Multiply by 3. What is 2 times 3? So 6x minus 3 equals 6. What do I do after that? Add 3 to both sides. So 6x equals 9. Next. Divide both sides by 6. What is 9 divided by 6? 1.5. Or I could reduce the fraction down. What goes into both 9 and 6? 3 goes into both. And so I could also write this as the fraction what? 3 over 2. Very, very nice work today. Your homework assignment, which is the second worksheet, you should have picked that up yesterday, is due tomorrow. You could also do the problems out of the book. If you don't have a copy of the worksheet, that is right over here in this red organizer for papers.